Okay, so now we are going to start, and I'm going to tell you what we have been doing at Contentsquare with Clickhouse this year. Please, speak after. So we are going to tell you what we have done at Contentsquare with Clickhouse this year, and it was a busy year. And first, allumé. So first, we're going to tell you what we are doing at Contentsquare so that you can understand our use case. Then we will talk about the migration we have done and some of the challenges we had during this migration. But first, my name is Christophe Calenzaga, and I am a data engineer. The data engineering team is a team that manages everything related to data at scale. And here is Vianney Foucault, who is a platform engineer. The platform team is more or less the DevOps team in other companies. So they manage automation, CI, monitoring, and so on. And both teams are working closely with each other when it comes to creating a new infrastructure, such as the Clickhouse one. A few words about Contentsquare. So what we are doing, we are an analytics company. We help our clients to understand their website or their mobile application. So let's say you are browsing through one of our clients' websites. We will be collecting the interaction you have made with the website. For example, the fact that you have clicked on the menu, the fact that you have scrolled, the fact that you have spent 2 minutes in the home page, and so on. And using all this information, we will be able to tell our clients that, for example, on average, people who have clicked on the top banner of the home page have made a purchase of 50 euros. And we are collecting 1.3 terabytes of data per day. And since we are keeping 13 months of data for all our clients, we are keeping 500 terabytes. We have more than 600 clients all over the world, and since they are on multiple time zones, we need to be available 24/7. And on average, our clients are making 60,000 queries per day, and I'm talking about analytical queries, so group by, joins, and not just simple CRUD queries. Now, here is an example of what we are doing. This module is called the zoning module. So a client can define multiple zones on the fly. In this example, he has defined 6 zones, and we will show a metric for each zone. So in this example, we are showing the click rate, which is the number of people who have clicked on the zone divided by the number of people who have seen the zone. And it's quite a challenge because we are providing more than 40 metrics, and our client can even define their own metrics, which means that we have too many possibilities to pre-compute. Moreover, some clients have a lot of data, and sometimes they like to have more than 100 zones. So we need to have a system that is powerful enough to process ad hoc queries within a few seconds. So now that you know a bit about what we are doing, we are going to speak about our migration. But first, I have a question. Can someone tell me what this graph is? Okay, I see some, okay. So I will tell you, basically, this is the evolution of the memory usage of an Elasticsearch cluster. And yeah, I know, when you see at the left, so we have started the cluster, the memory usage is low. Then it goes up, it goes down, up, down, and it's normal, it's how a Java virtual machine works. But if you look deeper, you will see that on average, the memory usage increases. And it's pretty obvious at the end on the right because the memory usage increases and never goes down, which means that this cluster is going to crash. So the good answer was a cluster that is going to crash. So now I have another question for you, an easy one this time. What is this graph? Ah, my bad. So, yeah, okay. So you didn't know, but this is the crash of an Elasticsearch cluster in production. And basically, the cluster is asking for more memory, but all the memory is already used. So it crashes. And this was our situation 2 years ago when every day we had a critical issue in production. And let me tell you that when you need to wake up at 2 a.m. in the morning, you are very upset. And this is one of the reasons why we wanted to leave Elasticsearch just after our migration to Elasticsearch. Yeah. But in fact, we had issue with stabilities because we wanted to put too much data into Elasticsearch. So we have added more server, but then the cost was too high. So we wanted a new technologies in order to reduce the cost by a factor 3. Then we had other issues with Clickhouse because with Elasticsearch, not Clickhouse. Elasticsearch because it couldn't scale. So we could add new clients by adding new clusters, but we knew we couldn't handle a huge client like a Facebook, like a LinkedIn, because only one query would crash the cluster. And another issue was the lack of analytics feature. For example, we wanted something called a marketing funnel, which is you want to know the number of people who have seen page A, and you want to know the number of people who have seen page A, then page B. This is not possible on Elasticsearch if you have a lot of data. So we looked on the internet for many technologies, many big data technologies, and in the end, we decided to go with Clickhouse. So the question is, why Clickhouse? The first answer is that Clickhouse is open source, and it was important for us because we wanted to be able to understand the technologies if we have an issue with that. And Yandex team made a great job to translate all their Russian comments into English one in the code. So you should read the code, it's easily understandable. Moreover, Clickhouse is very fast. We have used many big data technologies at Contentsquare, like Hadoop, like Apache Spark, like Amazon Redshift or Amazon Lambda, but Clickhouse is way better. And not only that, because Clickhouse is free. For example, we have thought about some technologies like Vertica or SAP HANA, but when you see the license cost, it's very expensive. Another thing for us is that Clickhouse was made by people from Yandex Metrica, and Yandex Metrica is an analytics tool. So we thought if some people have made technologies for use case close to our use case, it should work for us. Another issue we have with some technologies is that currently we are on AWS, but tomorrow we will be on GCP or on Azure. And we could have chosen some technologies like Google BigQuery or Amazon Redshift, but the day we would switch to another cloud provider, it would be very difficult. The last aspect was the community. To be honest, at first, we were a bit afraid because we thought only Yandex were using Clickhouse. But we soon discovered that other big companies are using Clickhouse, like Cloudflare, like Bloomberg, like Spotify, and like many big Chinese companies. Moreover, at the time, we thought that the community would grow, and in the end, I think we were right, because if you see the number of people we are tonight for such a niche technologies, I think it's not that bad. So this is what we have done. So last year, on March, we started to work with Clickhouse on our brand new analytics solution for mobile. We decided to test Clickhouse on a new solution because it was easier for us to not have legacy code. And within 4 months, we were able to ship this new solution in production. We were happy because Clickhouse was fast, was cheap, but still we have some doubt about how well it would work for our web analytics solution, because at the time, the mobile analytics solution didn't have all the advanced features of the web analytics solution. But still, in August, we started working on Clickhouse for our web analytics solution. And within 10 months, we were able to ship the new solution in production and to start the migration of the first web client from Elasticsearch to Clickhouse. Then we did a migration batches by batches. We didn't want to do a migration of the full 600 clients because we were afraid we could have some performance issue or data issues. So we did it step by step, and only a few days ago, we migrated our last client from Elasticsearch to Clickhouse, which means no Elasticsearch anymore, so we are very happy. But it leaves a new question: was this migration worth it? Because it took us a year to switch from Elasticsearch to Clickhouse. So I need to remind you that we did this migration in order to reduce the cost by a factor 3. And in the end, Clickhouse is, suspense, big suspense, big suspense. It's 11 times cheaper. So we are very happy. We are saving multiple millions per year using Clickhouse. And it's not just that, because on average, the queries are 4 times faster on Clickhouse. And I am talking about an average, which means that a fast query on Elasticsearch, let's say a 200 milliseconds queries, will be a bit faster on Clickhouse, like 100 milliseconds. It's good, but it won't change a lot in terms of user experience. But for the slowest query, the slowest out of 100, the ones that were taking more than 15 seconds on Elasticsearch, they are now taking less than 2 seconds on Clickhouse, which means that we are 10 times faster. And it's great because with Elasticsearch, some clients were complaining because we were too slow, and now they don't complain anymore. Another great news is the stability. We have used Clickhouse in production for more than a year, and we didn't have any major issue. Moreover, in terms of performance, the latency were rock stable. And the last good news is the storage, because when we went from Elasticsearch to Clickhouse, we have reduced a lot the number of disks, but even with less disk, Clickhouse can store 6 times more data, and this is mainly due to the fact that Clickhouse can compress data very well. So to sum up, we are very happy. In Contentsquare, everyone loves Clickhouse, even though many of them don't know what Clickhouse is. Yeah, but the important thing is that we didn't achieve such a success because we were lucky, but because we took time to understand how Clickhouse works, and we took time to see how to fit our use case into Clickhouse. And make no mistake, we had a lot of issues with Clickhouse during this migration, but every time we found a solution. And the rest of this presentation is about some challenges we had and the solution we found. And the first challenge was about insertion, because Clickhouse is great if you want to insert data, but if you want to insert a lot of data, you will have some issue. And for example, during our migration, we wanted to do some benchmarks. For example, we needed to reinsert 3 months of data of all our clients. And we knew that even in production, sometimes we would have to reinsert data, or we would have some spike of insertion, because most of our clients are e-commerce clients. So, for example, during the Black Friday, we will have a huge spike in terms of insertion. And Clickhouse is not great with massive insertion, because when you are doing an insert into statement, Clickhouse will parse all the fields in your statement and will transform them into C++ type, and this costs CPU. Moreover, Clickhouse will have to keep all the elements you have inserted in memory in order to transform them from row to column. But thankfully, there is a solution provided by Yandex, is to use the native format. So basically, it's the format used by Clickhouse, and you can insert native format into Clickhouse. But it's a bit tricky to use if you are not using C++, and in our case, we are using Scala. And we will see in the next slide how we did that. Another issue is when you have a cluster, you will use distributed tables. They are great, but when you want to insert into distributed tables, you will have some issue, because if you are inserting into a distributed table, what's going to happen is that only one server will take the full insertion, so the full CPU and memory overhead. Then this server will have to spread the data in the other server of the cluster, which means networks and disk overhead. So this time, the solution is to bypass the distributed table and insert directly into the right server. And this is what we have done with a tool called Clickhouse Inserter. So in this Clickhouse server, each server in this Clickhouse cluster, each server has its own dedicated Clickhouse Inserter. And we use a bit of trick. We use the same partition logic in Kafka as the logic we use for sharding data in Clickhouse. So it means that for ClickHouse, there is a given number of partitions in Kafka, and we have the guarantee that the data in this partition belong to only the given server. So our Scala application pulls data from Kafka. Then it will transform data into native format using ClickHouse Local. So ClickHouse Local is an embedded ClickHouse provided in the distribution of ClickHouse. And then once we have native format, we will insert the data into the right ClickHouse server. And again, we will use another binary in the ClickHouse distribution, which is ClickHouse client. And with that, this is great because now all the overhead of the insertion is in the Scala application and not in the ClickHouse cluster, which means that the cluster can focus on latency of the queries, which is what we want. And now let's say that tomorrow it's the Black Friday. All we have to do is to push a button on Jenkins, and we will have new instances of ClickHouse inserter. So, problem solved. Now, here is the second challenge we had, a huge one. It is how to design query in ClickHouse. Designing queries in ClickHouse is easy, but designing optimized query in ClickHouse is not that easy. And there is a reason. It's because there is no optimization in ClickHouse. You need to know what you are doing. And ClickHouse has some subtleties, and we will see some of them. For example, by default, no, not by default, ClickHouse will evaluate all the conditions of a query. So here is an example. Let's say that I want to count the records that match condition 1 and condition 2 and condition 3. Let's say that condition 1 is a very easy condition, like my field equal 1. And now, let's say that condition 3 is a difficult condition, like a huge regular expression. Imagine that 4 times out of 5, condition 1 is false, which means that the whole result will be false. Even if condition 1 is false, ClickHouse will still evaluate condition 2 and 3, which means that 4 times out of 5, ClickHouse will waste a lot of time to evaluate useless conditions. So there are many solutions to bypass this problem. One of them is to put condition 1 in a pre-where filter. Another weird behavior about ClickHouse, but this one, it's a good one, is that if you have in a query multiple times the same condition, it will be evaluated only once. Again, here is an example. So I want this time to count the number of records that match condition 1 and 2, and I also want to count the number of records that match condition 1 and 3. I could have done that with 2 small queries. But doing that in only one query is better because ClickHouse will see that condition 1 is used 2 times and ClickHouse will only evaluate condition 1 only once. So sometimes it's better to have a huge query instead of small queries. Another issue with ClickHouse is that even if it's very fast, but if you have too many subqueries or joins, it will be a bit slow. And you have other subtleties in ClickHouse, and alas, not everyone can be an expert in ClickHouse because it takes a lot of time. And in our team, in our data engineering team, we are 30 people, and half the people have never used ClickHouse. And the question is, how can they use our code base without breaking something? And this is why we have built an in-house optimizer. And let me explain you. So basically, we have multiple web services. And for a web service, at start, we will use a business language to describe what we want. For example, we want the number of sessions that have seen the home page, or we want the number of clicks of a given zone. Then we will translate this business language into a technical one, and this technical language will describe what we want to do in ClickHouse. For example, we want to do a count from the session table, and we want to apply a filter, which is a subqueries, and this subqueries applies on the page view table, and the condition is that the URL must match the pattern home page. Once we have this technical language, we will apply the optimization. So we will apply multiple rules we have learned with this migration. For example, if a given field have too many equals condition, we will transform all the condition into only one in. Or if the queries have more than one subqueries, we will try to merge all the subqueries into a huge one. And once we have optimized this technical language, we will generate the real SQL query that will be sent to Clickhouse. And what's great with this workflow is that if a newcomer comes in the team, he doesn't need to know how Clickhouse works. All he needs to know is how to go from step 1 to step 2, which means how to use our translator. And to give you an idea, some queries are 6 times slower if we don't use our optimizer. The next challenge, a big one, is how to reduce the storage cost. And it's an important one because if you have a data warehouse, most of your costs will be your disks. And to understand how to reduce the cost, you need to understand how Clickhouse manages data during a query. So here is an example. Let's say I'm doing a query in Clickhouse. First, Clickhouse will read the query. Then it will ask the file system the data needed for this query. And it's important, it will use the file system. It won't fetch by itself the data on disk. Then it will decompress the data because by default, the data are compressed in Clickhouse. And then it will process the data. The yellow part is important because this is a concept of cold and hot querying on Clickhouse, and in some other database, this is not the same concept. So basically, Clickhouse don't have any caching mechanism. It relies on the OS file system, and it will rely on the cache of the file system. So let's say I want to know the number of people who are 12. Clickhouse will ask the file system the data of the age column. And for the first time, the file system won't have the age column in cache, so it will have to fetch the data from disk, which will be slow. Then it will put the data in its cache, and it will give back the result to Clickhouse. Now, let's say that I'm doing another query, not the same, but using the same data set. So this time, I want the number of people who are 19. Again, Clickhouse will ask the file system the data from the age column, but this time the data are in cache. So it will be very fast, even if the disks are slow. And we will see in the next slide why this is important. The other important concept is the compression. So basically in Clickhouse, you have 2 types of compression codecs, the generic one and the specialized one. So the generic one are ZSTD, LZ4, or you can even choose not to compress. They are great because they will work in all your data, whether they are string, integer, or so on, and whatever the distribution of data they have. But there are pros and cons. For example, you might choose ZSTD if you want a better compression ratio, so if you want to save storage cost. But if you do that, the decompression during the query will be slower, which means you need to choose between ZSTD or LZ4 in terms of fast queries. But sometimes you can use specialized compression codec. For example, and for these codecs, there are no pros and cons. They will work well only if they fit some pattern. For example, for dictionary encoding, which are low cardinality field in Clickhouse, if you have, let's say, 1 billion rows in a column, and you only have 100 distinct value, it will be very great. And again, you have other algorithms like Gorilla, which is great for time series, T64 for numbers, and Delta if your data are doing some patterns. But the most important thing is to understand the pattern of your queries. Because let's say you have a table with 100 columns, and if you look at the queries done in your database, you might see that some columns are practically never used. And if they are never used, it should be great to compress them a lot, for example, using ZSTD. Yes, the query on those columns will be slower, but since they are never used, you don't care and you can save money. Another important thing is to see if your users are using the same data set. It's important because maybe the first query will be slow because the query will be cold, but since the user are using the same data set, all the rest of the query will be fast, which means that even if you have a slow disk, your database will be fast. Another advice is to benchmark on realistic workload, because to give you an idea, 1 year and a half ago, we did a benchmark, and we tried to see if what was the best between slow disk and fast disk. So we did a benchmark on the worst case scenario. What we did was to take a huge client, so with a lot of data and with a lot of columns, and we were assuming that the query would be called whatever, will be always called. So the result of the benchmark was that Clickhouse is 10 times faster on slow disk than on fast disk. No, it's 10 times faster on fast disk than on slow disk, my bad. But then, a few months ago, we did a benchmark using real queries from production, and this time we discovered that the faster disks are only 20% faster than the slower one. And the faster disks are twice more expensive than the slower one. So basically, we decided to go with the slow disk because in terms of performance cost ratio, they are the best. New challenge, this one not really a click-out challenge, but since we did a huge migration, of course, we did some bugs and we had functional regression. In fact, we had 4 main reasons of functional regression. Basically, we had to modify the data pipeline in order to insert data into Clickhouse. And when we did that, we did a few bugs and we were losing some data. Just a bit of data, less than 1%, but it was messing with some queries. So we have fixed that, and then we have seen that even in production, in our Elasticsearch pipeline, we have some data loss. So it was a bit difficult. Then, since we had to write all our SQL queries for Clickhouse, we did some bugs, which is obvious, and we were able to fix them. But again, we also saw that on our previous infrastructure on Elasticsearch, some queries were not doing what we were expecting them to do. So for some of them, we agreed with the product team to fix them, but then when we saw how huge the gap was, we had some time, we had to roll back to the old behavior, which is bad, but it's life. It was very difficult to spot the regression because we knew the data was not exactly the same in Clickhouse and in Elasticsearch. Moreover, in Elasticsearch, for some metrics, we were using approximation, and it's difficult to compare approximate number versus exact number. And the last issue was that even if we are computing metrics, we can put more parameters that will modify the behavior of the computation. So I will give you an example. Let's say that I want the number of sessions, but I could also want the number of sessions of people using Chrome. And we have a huge number of possibilities, so it's not possible for us to test all the possibilities. And in the end, this is what we have done. So basically, we have took thousands and thousands of calls in production, and we have built a tool called Comparator, and we have replayed the queries on Elasticsearch, then on Clickhouse, and we have computed the difference between Clickhouse and Elasticsearch. And using this tool, we were able to have, for each metrics, the statistical distribution of the difference. So to give you an idea, for the number of sessions, we knew that for 80% of the queries, the difference between Clickhouse and Elasticsearch was less than 0.2%, which was great. But for the worst 5%, the difference between Clickhouse and Elasticsearch was above 30%. And knowing that, we were able to focus only on the queries that were too different between Clickhouse and Elasticsearch, and we were able to find the common patterns between all those queries and to find the root cause. Of course, it was a very long process. It took us multiple months, and we had to do multiple cycles. But in the end, during the migration, none of our 600 clients have complained about any data regression. So it was a huge topic, and if you are interested, we did a talk on Data X Day, and the video is available on YouTube. And now I will let Vianney talk about the fifth challenge, a huge one, which is how to make ClickHouse production ready.
Thank you, Christophe. So I'm a platformer, I'm a Devops engineer, and my role is to make system running, to give the proper tooling to all the teams of Contentsquare, I mean the R&D, to be able to work properly. And so, are my system performing well? I have a ClickHouse cluster running for months in production, fine, and then my boss come to me. Will the pipeline be able to handle twice as much load as today? Well, maybe. Or can I answer this question? And it's all about observability. So observability is how to be able to get the relevant metrics from the system, because I need to know how the CPU is going, how the memory is going, disk and so on, but also from ClickHouse. And with ClickHouse, we do have a lot of metrics that are exported with some tools that we will see afterwards. So I want to be able to say how much data is inserted in each chart. How about from the replication queues? Is the replications working well? Do you have maybe a huge lag between two replicas? And also the ClickHouse query time. It's important to me to be able to tell if some queries are taking longer and longer day after day. Also, you have to be able to get the relevant logs. It's all about the ClickHouse error logs, the logs from ClickHouse itself. Also, my application logs, everything on Kibana. And whenever a microservice is querying on ClickHouse, and I have a 500 error in my microservice, maybe I can correlate this with some error from ClickHouse, maybe on timeout or something. And with all of this, I am able to create some relevant alerts. So I want to set some alerts that are meaningful for my production and that are not like useless. If the disk is filling, should I wake up someone in the middle of the night? If one shard is completely down, should I wake up someone in the middle of the night? This is all the alerts that I have to sync and to set up for the teams I'm working for. So this is the set of tools we are using. Most of you might know them. So it's very common: Prometheus, Alert Manager, Grafana, and so on. And we then have to deal with some issues that might happen in production. So whenever, we don't do that, but maybe one day someone by accident will drop a table in production. And then you have two options. The first one is to pray. Maybe someone will notice, maybe not. Or maybe you can restore data. But to restore data, you will have to backend them first. And backup yourselves, because data loss is coming. So whenever you drop data, and if you have no choice but to reinsert all the data, it can be very long. Okay. So for that, there's some features that are not yet built in within ClickHouse, which is backup, restoration, and also data expiration. Okay. But data expiration came in maybe this version, right? Yes. But we can't use it because we're not yet at this version, and to implement the expiration within ClickHouse, we would have to rewrite our model. And also there is a cool feature with ClickHouse, which is ClickHouse Copier. If everybody knows ClickHouse Copier? Yeah, 2 people. Well, it's amazing. It gives you the ability to reshard data from a cluster to another. But you will have to write a long series of XML files, put everything into Zookeeper, and then you will have to run on ClickHouse Copier from every machine you want to copy data from or to. And if you want to scale from 10 shards to 100 shards, it can be a nightmare. So we had a few challenges, and we wanted to be able to copy partitions of ClickHouse, of parts, to an object storage, whenever it is with AWS or GCP. We also wanted to be able to keep track of previous backups. I want to be able to tell that these parts come from this shard, this machine, and so on. I want to be able to update partition data, because with a merge tree engine, you will have some merge and then new parts, and you will have to expire data on your object storage to put like new backups. We wanted to be able to clean up backups, because at Contentsquare, we do have an engagement with our customers, is that we won't keep data for more than 13 months. That being said, at some point, we will have to issue some drop tables, or not drop tables, drop partitions, sorry, just to get rid of the not funny expired data. We want to be able to perform some extra administrative tasks, such as create users, fetch some information on the cluster, and so on. And also, we wanted to be able to orchestrate ClickHouse copier, because it's not that easy to use. And here it comes. We have something under the hood, which is dealing with data expiration, major disaster, like backup restoration. On cluster extension, for whenever I'm adding a new shard to my cluster, I want to be able to reshard data. Staging refresh, if I want just to copy data from the production to the staging or any other cluster. And also to deal with upgrades and so on. And this is a tool named ClickHouse Companion, which is like built at Contentsquare, or written in Go and orchestrated with Apache Airflow. So the tool is very easy to use, and I will just illustrate one simple use case. So the funny use case is, we don't do that, but maybe one day. Maybe one day we will scale from 10 shards to 100 shards. Okay, I have two choices. The first one is to reinsert all my data, which I don't want to do. Or maybe I can just copy data from a cluster to another. And so one does not simply use ClickHouse Copier. It's not that easy to use, it's well documented, but still you have to orchestrate it. And this is our job. So basically, we do empower developers at Contentsquare to be able to use a simple Jenkins server with a few steps. You have to specify the source cluster, destination cluster, the partition, if any, like all or one, maybe a filter if you want to filter out data, and so on. And then everything will be running automatically. You will have your task created within Zookeeper, and then you will distribute your task on your destination cluster, and then the destination cluster will start with the proper level of parallelism, the ClickHouse copier task, and everything will run nicely, and maybe like in 2 days, your new cluster will be fed with the resharded data. And we decided to do it this way. I mean, starting to copy data from the destination cluster, rather the other way around, which is more effective, to not impair the source cluster, the production. We are the platformers, so on Slack, you can call us @platformers, but only at Contentsquare, obviously. And maybe a developer one day will say, hey, platformers, would you deploy me a ClickHouse cluster, please? Well, no, this is not our job. Our job is to deploy tooling and to empower developers to be able to deploy their own cluster. So deployment, now it's easy peasy, okay? And we have some tools that you may know, which are on Terraform, with a simple set of scripts we wrote. Also, we do have Ansible to deploy like all related to ClickHouse, so the binaries, maybe the users, the configuration for all the clusters, and so on. And then we have Jenkins. Here it again. Jenkins, developer will go to Jenkins and just click deploy that cluster, and then in 30 minutes, like maybe we love to make developer wait. So 30 minutes, we have some pause within the deployment stuff. The cluster will be ready. And the sole thing you will have to do is just to feed data in with ClickHouse copy or orchestrated, or maybe you want to restore data from a cluster. And here's just a few takeaways I can give you tonight, because we're on a rush. First is automate as soon as possible. So we didn't start to automate ClickHouse and all around ClickHouse like last month, before going to production. No, we did it like more than a year and a half ago, when we started to work benchmarking, seeing if ClickHouse would fit our needs. Use common metrics to define custom alerts. We have a lot of metrics, and maybe you don't need to create new ones, and maybe with an alert and another one, you can define a situation that will trigger the proper alert. Empower developers. we are platformers, DevOps, and we don't want to be a bottleneck, and we don't want to be the center of attention to be able to perform some nasty tasks on servers. Okay, we want to give the proper tooling to developers to be able to work by themselves to go further. Test your tools. Okay, it's obvious, but we don't migrate cluster every day, so we are sure that Clickhouse Copier is well orchestrated with our tool Clickhouse Companion. Bench and don't guess. We didn't come up one day saying, okay, my cluster will be like, I don't know, 100 shards, and maybe I will take that kind of instances, that type of disk, and so on. Okay, we tested stuff, we had some ideas, we benched everything, and at the end we had some proper insight to define the proper architecture we should use for ClickHouse, how we do design tables and so on, and the infrastructure itself. Take your time to understand ClickHouse because it's not something as trivial as it sounds. You have, Alexi said this before, you have a way to query the table, but there's the analytical way to query a table. And that's it. It's Q&A time. Thank you all.